Welcome back to Made Up of Wires, where we are decompiling this Hacko. What is it called? I don't know. Helping Hands. It's not really Helping Hands. It actually is one of the coolest things. Substantial. Probably weighs 2.5 to 3 pounds. Clamp it down on your electronics work that you want to do. Solder it up. Much nicer than Helping Hands. It has nice rubber pads to keep things in place. Keep your stuff safe. Hey, does it? Good to have you back. I'm gonna turn my volume down here. I'm hearing a lot. All right, there we go. No, we're decompiling Castlevania Symphony of the Night, of course, and you can go to soten.z.dev to learn more about the Castlevania Symphony of the Night decompilation project. This is a matching decompilation project, which means we want to recreate source code that will compile to exactly what was shipped on the PlayStation, the PSP, various versions of the game. I'm a big fan of matching decompilations because you know whether you're right or wrong. And so we're going to keep working on Richter today. That's what we've been working on. Not Richter, the player character, but Richter, the boss. And what has happened since we last met? I didn't stream yesterday. Yesterday was a holiday in the United States where I reside. And so I took the day off and had steak. Not that I can't have steak when I stream, but it's better when you can have a relaxing day. So we were working on that. I went through and tried to split out importing the overlay from all the decompilation work that we've done so far, and I was able to get things matching that I hadn't gotten before with some persistence. So this has mostly been cleaned up. I struggled early on with eCollect. It was split between eCollect Blitchar and an eCollect 2, which was an older split that we had. I'm still not convinced that I like the monolithic file. The monolithic file makes it extremely difficult, from my perspective, to match when you run into issues. And what are some of the issues that you get with eCollect? Mostly, you have a bunch of settings that you can define through macros. And if you don't get those right, everything blows up. And so the magic number here was 0, but you need to know that beforehand. So we got that done. So we're going to go back to working on Rick Main. Oh, the other thing I did before getting that in is went through... Let me back up, actually. A few... Last week or the week before, I submitted a PR to make it easier to run the duplicates report. And now it's super easy to run the duplicates report. You can just say, make duplicates report, and it will run it. Before, you had to go through gymnastics, and what would happen was it would destroy your environment, obliterate your symbol files, kick your dog, and a bunch of other things. It still takes a while to run. Believe it or not, this is about 1/10 of the time that it used to run in. But you can run the duplicates report, and when it's done, you get a nice file. Let me unwrap that. There we go. And so I went through this, and I looked for things that hadn't been decompiled yet, that were also in BO6. What am I looking for? Let's just look for BO6. BO6 not in here? No, we have BO6. Let's do it this way. And then not only things that were in BO6, but things that also were named FunkUS. FunkUS is the default name we have for overlays, the prefix, the VRAM address. Some of these I still left. I did not create symbols for them, but most of these are gone now. I left them in place when either the other duplicates that were in that same cluster didn't have names or didn't have obvious names, or like the ones at the start. There's decelerate X and decelerate Y. I would have to go through and figure out which one is which. They're not always in the order that you would expect. There's this one, debug, but debug and debug prologue. You have to figure out the difference between those two as well. They probably just set some global addresses. Set velocity, that's probably straightforward, but I wasn't sure and didn't want to go through that. So tons of new symbols, and so I created a new scratch that we'll keep working on for Richter main that has all of those symbols in it. I was working on the PSP version. I didn't want to spoil too much, so I will just kind of start where I was and go through some of the things. So this Richter main function gets called by the Richter entity update. So every frame, it's going to get a chance to do things, and the first thing it does, if you may or may not remember, is counts down a bunch of timers. There's 16 timers that the Richter boss has, which is the same as the player. And it counts each one of those down. If they're at various states, different colors do different things. PLT4, for example, will scroll through some colors, cycle through some colors. Invincibility will set, basically increase a timer, and then these will count down. And then when there's 0, different timers do different things. And some of those we know: poison, curse, those are obvious. Attack, run. Some of them we don't know, and that's why we just give them a number for now. But I was going down here, which is where the Richter state machine is, and that state machine is tracked through step. And the first time we go through, we determine what the current step is and then take some action based on that. Then we want to, as a result of that action, Richter may have changed, so we're going to go through it again and then set some flags. And so that's where I wanted to start today. I was messing with this to try to get it to match. I reverted some of my changes to go through what's going on. So this is a jump table. This jump table has a lot of entries, and the way that Metro works on the PSP compiles that is as a huge series of if-else statements. That happens when there are more than some number. I don't know what the threshold is, but some number, and that those entries are sparse. And so in this case, we have up to hex 70, which is like 144, somewhere in there. $112. And so that must be beyond what MetroWorks will generate for a jump table. And so it does all these if-else. At least MetroWorks when it's not optimized. We might see something different in the optimized state. So, kind of walking through each of these states, fortunately they're in the order that they appear in the source. I noticed that as I was refactoring this, I got rid of a status set here. It might be nice to look at what that flag is. It possibly is unknown at this point. So I want to go through and see where do I have any differences that don't have to do with symbols. The first one I see here is on 315. I have I have a D when it should be an 8. And that comes from this OR. It's the top 16 bits of this 32-bit number. I don't know if it's different between the PSP and the PlayStation, but I'm going to assume that they're the same for now. I'm going to keep going down. There is an OR down here, on 340. So we're not just setting the status, we're oring the status, which means we're setting a flag on the status. We're doing the same thing on 345. And again on 350. I think I had these and I've flipped back and forth as I flip between the PlayStation and PSP versions. Sometimes by correcting one or thinking that I'm correcting one, I break the other one. All right, so we have an OR here. That OR is being assigned to register V0, which is used for intermediate or ephemeral values. And then that's getting written to S3. So what we actually have here, and thank you PSP for letting us know this, we're doing an OR equals up here, and then we're setting status down below. That might not make a difference on the PlayStation, but the PSP does, and it might affect how registers get allocated. That actually was, let's get that, 98.6. Looking at this number up here, which is how similar is this, there's 1,290 edits necessary to get to our final status. And that gets us a little closer, just a bit. So I know that we're going to have symbol differences, that's fine. I'm okay with that. As long as it's the same mapping on both sides and consistent, that's okay. So I don't see much else down here yet. That all looks fine. Oops, too far. Oh, it's too far. Let's go back up here and see what's going on. So we do have a jump table up near the top, around line 125, and I was mucking with this, trying to get this ordering correct. Often the RO data won't be the same, but it'll be off by something consistent. And so in this case, the original was 48, and mine is 8. So as long as consistently these are off by hex 40, which is decimal 64, I would be okay with that. But most everywhere that's true except for this break at the bottom, which seems wrong. This is an implicit break. And this list at the top on 125. So something is incorrect with these. I looked a little bit. So there's this is the list of timers. I'll go through and just make sure that I have all of them. So Poison Curse 234, Poison Curse 234, 5, 6, 7, 8 attack. 5, 6 is in the wrong location. I'm going to move it up, but I don't think it can go up here. Yeah. We need to keep it in the right order, and we need to keep the right label. Yeah, I am thinking that it is a case ordering issue, but is it... Are all these pulled to the end? Maybe some are missing. Invincible, invincible after image. Invincible, invincible after image. So there's a couple things that could be happening. All these breaks could be pulled to the end. I have tried to get rid of them. Often we'll have a default at the end, and that might give me... Sometimes that will generate code. In this case, it doesn't. That's okay. Let's see what happens if I get rid of all of these, because they're not necessary if they're just going to break anyway. Oops, too much. I lose the jump table, and I need the jump table. And this goes back to a branch then. So there's some, there's something I'm missing here. If we look at the decomp doesn't list any of these. I do want to go through and make sure that I have the right ones. So we're at this second switch here. So we have our 8222, that's this one, 8220. Setting color blend to false. Our call to invincibility frames. Our animation call down below. And then our after image disable. Let me make sure that so 6, case 6, yes. Invincibility scene, let's make sure that that is 13, yes. 15, after image. Dizik is saying... are they joined through default and just fall through? Yeah, possibly. So we need them... let me get back to this assembly. We need them to generate our jump table. Unfortunately, this doesn't do anything for the PlayStation. It's... Oh, this is interesting. We have a 170. That's too late. This S3 versus S2. So this is going to be part of, I think, this load here. Look in the right place. Yeah. This is wrong register, but it's part of the for loop. The hex 40 away is these correct RO data ones. So if we go back and look at like what that jump table looks like. Not the first one, but the second one. Oh, and the 40 could be because I put these in the wrong order when I created it. Yeah, so the offsets just need to be relatively correct, not absolutely correct. This could be enough, possibly, though, to get a match on the PlayStation. Let me see if I pick one. All right. So here's what our jump table looks like. If we put it side by side, oh, you could do it. What we should see, let's continue looking for that. All right, so we're loading the jump table here. We should see labels that correspond with all of the entries in this table, and we can go through and number those or index those. So we know now what the we have all 15 entries. These top 4 are all breaks. And so going back here, we want to make sure that 0, 1, 2, oh, no, I was wrong. The top, let's look at this one. 0, 1, and 3 are breaks. 5 is a break. Basically, all of these need to end up being breaks. This doesn't tell us necessarily where they occur in the order of the switch, just that when we hit that index, it should be a break. If we look at what that label is, I would expect that label to basically, this is where we're about to loop in the for loop. So we're adding our 1 to the index, and then we're going to go back up if we haven't hit 16 yet. So we need all of those. One thing we can do is get rid of the... Sorry, I was over here. All the ones that break immediately are going down here. So what I want to try to do... the first thing I'm going to do is get rid of the enum labels, because I know that index 2, 4, 6, and then 13 and 15 are the ones that I want, and maybe there's something there. I know that that is what I have already, but let's try it in case something else is going wrong. So again, this has to be in this order. We can verify that this is the right thing as well. I'm gonna try it and see what happens. We'll put it in the right order. 13 and 15. I'm gonna get rid of. Sorry. I'm putting these in the correct order, even though I don't think that they should be. I'm gonna get rid of the other cases. So this will generate the wrong thing, and I'll go back through and put the right thing in. So then we'll go through and put everything else in that's missing. Let's see what the threshold is for generating the jump table. So it was 1, 2, 3, 4, 5, 6, 7, 8. We have 8 right now. We still don't have a jump table. Here's 5. Does 5 give us? 5 doesn't give us a jump table yet. Somewhere in there we got it. Oh, I forgot my brakes, which may or may not have influenced it as well. And so yeah, we do see that this is wrong. We still have that offset of 40 between them all, and so that was correct to put those in the wrong order. Eek is not a brake. And we have the wrong set up here as well. Oh, this might be coming from this other table. I didn't even think of that. Let's go up and look at this one real quick. This set maybe. Yeah, I don't think that makes a difference either. What's these are the smaller numbers. Oh. This be 129? We're decrementing. Oh no, maybe not. I was gonna say, are we not breaking here but continuing? That changes that significantly. And that these are in the right. So what am I doing? These are cases that didn't match. So do we have some that are actually continuing? I didn't think of that. Let's look up here. None of these seem to have that same behavior though. I would think that we'd want to decrement them regardless. Revert all of this. Let's look at the PlayStation. See if it tells us anything. There's two things I'm going to do. I'm going to look at the PlayStation and then I'm going to go back to Richter. We'll look at Richter and we'll look at Doppelganger. Copy everything. That gets us very close, 98%. Still not perfect. Um, 88. Game timer is getting loaded strangely. It's getting loaded as a word instead of a half. Let's go down to that switch then. BO4 and... oh. Let me fix my OVL export. So here the RO data is matching. And that gets us through all of this. Set step here on 186. Dizik thinks it might compile matching code. There's other issues that there's the register issues as well in that area. I don't think we've resolved those yet. Are they resolved? Oh, are all the register issues resolved? Yeah, if it is just the RO data, I probably should just ignore it, honestly. If the register issues are fixed. They're not fixed on the PlayStation, however. So let's look. I kind of agree, though, that it probably isn't worth trying to solve that yet. Let's find the other issues. So we're finding symbols. More symbols should match now. Things within RIC and GRIC will not match. But functions should. Okay, so 334 we have a missing switch case. So, nope, next one down. One of these GAPI cases. 349. So we should be getting a couple of these falling into the same. My guess is that it's ending 2. We have this timer attack. Nope. One of these then should not have it. There we go. Let's look at this on the PSP again. So we don't have the time attack for ending 3, which makes sense that only ending 4 would have the time attack set. So either I have this wrong on the PSP or the PSP's behaving differently. So we are setting time attack maybe to different values. But it looks like this is a PSP exclusive thing. So let's fix that. Or a bug fix. And that fixes up that switch. RO data does not affect this number at all. It just gives us hints as to whether or not we got that correct. Everything else so far is looking really good. I think we're missing one thing. Two things we're missing. Let's see if we can fix those. Setting the status looks like it's out of order or not done at all. This may be a PSP fix as well. So I think what it seems like is when this code got moved over to the PSP, they had additional diagnostics enabled that weren't there earlier. And so we do see cases where uninitialized values like this do get initialized on the PSP. That is something that happens, and I think that was it. I think that might have been not all of it. G-timer issue, or which one was it? One of the ones down here where we're doing a load word instead of a... Oh, where did that go? Oh, we'll find it again. But yeah, that seems like a PSP change. Yeah, it doesn't affect the PSP at all to have that in there. But it's still working. Let's find that one bad instruction. My interest in the PSP version of the game is lower than the PlayStation version of the game, so I'm not going to focus on getting a match there, but the closer I can get it, the easier it is for somebody else to come through. Dizika on YouTube is saying that in the previous stream I had that symbol wrong. The symbols that show up on the left-hand side now are the current state of the symbols as they are. Did that fix that instruction too? How would that change a load word? I wish I had a replay button. I don't remember where this was. I'm not seeing any other issues, but I know that there was one more. There it is. I just saw it. All right, so we have a load word here for game timer. That's what it was. I couldn't remember the name of it. So what I want to do, we have a macro for this. We can wrap it in a macro and everything will be happy. There's a couple things that could be happening. I don't know what the type of this is. It could be that I have the wrong type. It is a unsigned 32. What's happening is the game or the compiler knows that this is masking the lower 4 bits. Yeah, lower 4 bits of game timer. And so it doesn't need to do a whole load word operation, even though from a cycle perspective, this doesn't really help. So why does it do a load half when it could do a load word? Let's try this. Let's try making the mask, casting that as a sine 32. Does that help? So what we can do instead is basically force this with this low macro. And that doesn't do it either. All right, so angle. We could do this. So we'll load the angle and then do a or equals. But it's, yeah, let's do this in a couple steps. Yeah, GCC is smarter than me. What is our angle? It's a sine 16. Oh. So if we make it a sine 32, Let's undo all that. Unsigned 32. That introduces a bunch of instructions that we don't want. And we need it in a variable because we don't need it in this variable. All right, let's go look at that on the PSP. The PSP will give us a little more hint as to how that might be being used. Whether or not we're assigning it to the same thing here. Yeah, so here we're doing exactly what I would expect. We only have one S register. Usually, if it is a variable, or if it's being assigned to a variable, it'll go into an S register. Let's try a few other tricks and see if we can force this. So I really want this to be we could do this and this would be a horrific, yeah, we can, misuse of memory. Basically forcing this stack variable to be treated as a 32-bit value when we know it's a 16-bit value. We can run into all kinds of issues with that. So let's try doing the casts. So we're gonna wrap this up, and we want our we want this to happen in the 32-bit domain as much as possible. What if we invert this? Going back to we really have to use the PSP kind of as a guide for what might be happening here. And I was going to say, can we do the shift first and then the and, but I don't think we can. We'd have to move the and over by 8 bits. So what I'm thinking is GCC probably won't compile this to the same thing either. But if we did something like that, yeah, it's not going to generate the same thing, even though that ends up being the same thing. So let's cast this as a sine 32. Let's get all the casts in here. And cast this value as sine 32, and if we get something that works, we'll revert it. Kind of one by one, go through, figure out which one. Let's go the other direction. This actually, we can't do that either. I was gonna say go the other direction and force angle to be assigned 32, or yeah, probably sine 32, because that's what's being passed ultimately to the rsine function, is a sine 32. But if we look at the PSP version and how these calls are made, sorry, that's happening up here. What we're gonna see is when that value gets put into A0, we do this sine extension, and that sine extension says take the value in S1, treat it as a 16-bit signed value, extend it to 32 bits and store the result in A0, which is the argument to rsine. So if we treated this as a 32-bit value, we'd have to do a cast to 16 bits before assigning it, and then we'd have to cast all of these to 16 bits. That wouldn't even work, actually, because we'd have a SEH instruction to get them down to 16 bits, and then an SEH instruction to get them back up to 32 bits. So that doesn't work either. So here's another option. This is a 32-bit value on PlayStation and a 16-bit value on the PSP. Uh, 32 bits just doesn't not work with this in general, though. Yeah, because we need the shifts. me get rid of all this garbage. Why do we get a shift left by 8? We're taking the lower 4 bits of the game timer, shifting them, but then we get a shift left by 8 here. Why not a shift left by 16? Casting the angle to sin 32 doesn't affect its deceleration. So what's happening here is this should actually probably be an unsigned 16. Maybe that will be the difference. No. That actually breaks it in a way that I didn't expect. Is there some compiler magic happening here? The shift by... I would expect a shift by 16 if this was trying to cast... So, that doesn't make sense either because it's a 1220 float. All right, so let me tell you a little bit about what's happening. We're taking the lower 4 bits and shifting them over by 8. And so that gives us 12 bits of data, with 4 of those bits being significant. That bottom 12 bits is a number, a radian from 0 to just less than 1 for our call to R sign. So we know that the value can't be greater than 1 radian. And that always will fit into 16 bits. And even with this addition down here, it'll always fit into 16 bits. And so really what we're left with is there a... Let's try. Let's pretend that there is a different variable. I don't think there is, but let's just, for kicks, let's try it. The other thing I should really be doing is oh, that sucks. I don't think this is going to work on the PSP. It might. Yeah, it didn't work on the PSP. It introduces a new variable here, which we don't want. Let's make it unsigned. Yeah, that doesn't make a difference. Okay. So it works, and it will. So this probably is a match now. It might be worth checking to make sure that it is a match. I don't like it. Let's go look at. I put off looking at Rick main for too long. I think I know where it is. Source Rick heal main and Rick main. So here we're doing the same thing. Game timer. Oh, that's it. So smart. Somebody's smarter than me. This is a stupid compiler trick. Not really stupid, but oh, it might not have worked. Did it work? It worked. Okay. So when you're doing, as humans, we think of like a shift by 8 and a multiply by 256 in the integer set of numbers as being the same thing, but a compiler doesn't necessarily treat those as the same thing and does some lower level optimization on the shift than it does as on the arithmetic multiplication. So that was it. And it could have been solved much quicker by just looking at work that other people did. Always helpful to look at what other people did. It doesn't affect MetroWorks at all. So let's see if we did it. Did we did it? Let's see. I don't know that I have all the symbols I need. This is a big one. So steps should be in the header already. I'll make sure that I have that. Yeah, I think this is all in place. So I don't need this, and it would be bad for me to include it. So I generated the duplicates report before. The duplicates report does generate a different set of AS assembly from the normal build, and so when you regen all of the assembly, it regenerates all of this as well. So it looks like I'm missing some enum values there, so this won't match. But we'll fix that. I renamed these last ones. And just to make sure that I didn't use those anywhere. We'll see. The compiler will tell us. Wait. Still not matching. Pretty small diff. That's good. All right, so we're off by 2. And we have a C instead of an E at 3597 C. So we'll go and look at that, and then slightly later we're off by X20. Nope. Looking at the wrong one. Same value. All right, so let's go look at what that is. So we're down here. So this is something in the Richter entity that is not mapped correctly or mapped at all. Let's find what that is. So let's see if we can figure out where this is. There's a hex 4000 around here. 40,000. So it is right here around 395, I think. And here's our E. Yeah, and this didn't get mapped properly, so let's go fix that. So whatever symbol I do have there is not right. I have 390 and 397. I have anim set. It looks it doesn't look like an animation set though. Okay, so first I want to see where this fits in. 632E. Yeah, so I had anim set. It's the field right after anim set. Animation current frame. So this will still fail. I'm gonna go fix it in decomp.me while that's going. And we did that 2 places. No. Yes, it needs the load and then it needs the store. So I fixed that in decomp.me. We'll go over here and fix it as well. So I said pose timer. Or an anim set, sorry, and it should be anim curve frame. And green, yes, very good. That was a big one, so happy to get that out of the way. And how does it look? I forget how it looks on the PSP. We've got rid of the register issues. So we don't care about immediates. Apparently the RO stuff is not going to matter. Sometimes it's hard to know what to care about. So it's going to match on the PSP as well, I think. So that's sweet. Let's throw these into context. And then we'll mark this one as matching. All right. And then I like to stage all of that. There's other things that I'd like to clean up, and I'm not going to do it on the stream, but I will do that later. So any of these BO6 prefixed function should be OVL export, just the function name wrapped in OVL export. Get rid of all the switch comments. M2C puts those in there to make it easy to follow which switch it thinks each case goes with. We don't have the right status flags, but if we do a format, SOT and lint, you'll see some of them came through. So we had dead, but this will come back through and replace that with flag dead. So if the step is dead and flags are dead, then we're going to do our thing. Our unknown status. Moving around some, not those entities. Moving around these entities. And then reformatting the code, not terribly important. I'm more interested in the statuses. So we get our hex 100 replaced with the flag dead. There's a status variable in there that's computing status along the way that will not get picked up. So we see these down here. That does not get picked up by our linter. It just looks at fields and not variables. Because there could be a lot of things called status. I can't guarantee that it's going to do the right thing. All right, so done with that. What do I find? Nope. So we're going to go to BO6 and look for what's next. So this is sorted by size. There is a lot in here. Some of these do have duplicated entries. I probably should clean and run this again. And limit it to non-matches. I'm going to do that. It might be nice to do cutscene. That's a relatively... should be relatively straightforward. We have a lot of examples of cutscene. I want to see how many are left, as well as try to find what so 128 left. The named ones, my guess is that many of those should, and we could choose a smaller one, many of those should be the same as the Richter player version. They will just be pointing to different global structures. So we could look at Hydrostorm, for example. Hydrostorm! Oh, that one's really small. And while that's going, find the... a Richter version. Oh, do we not have a Richter version? Rick Step Hydrostorm. And it might be good to break this up the same way. And yeah, so this is what I thought it was going to be. So we have player. That's going to be Rick instead of player. We have G player down here. That's going to be grick. Our set stand is going to be namespaced into B06. And other than that, a lot of these are going to be... Oh, shoot, I didn't want the percent. There we go. A lot of these are going to be the same. Of course, I could be terribly wrong as well. Oh, we have a bunch of this that just isn't there. Even easier. So we have symbol differences, but that's it. So I'll probably do a bunch of those offline as well. Let's do this. Let's look at Richter. Well, they'll be the same but different. Does it suggest another function from Rick entity? Yeah, we could do that. Cristiano says, what's the difference between player and G player? Player is an entity, and an entity could be anything that's animated or interactable in the game ends up being an entity, and it has information about what things to draw, information about its position, some custom data for that entity, but basically anything that you see on the screen is an entity. Anything that you see on the screen that does something that's not static is an entity. Otherwise, it could be a background tile or the background. And then GPlayer, or in this case, grick, that we're working on, is the current player state. So like what buttons are pressed or held, any timers related to it. It's significantly larger than an entity, so there's a bunch of data in there that just wouldn't fit into the entity object. And there's no dynamically allocated memory in the game, so either because it's a table of entities, either every entity would have to be big enough to be the player object, or it could be offloaded. And so for most bosses, I don't think most bosses are this way. I worked a little bit on Medusa, and I can't remember, but most bosses don't have the same player state, is what we call it, structure to go along with them. They're just an entity, and they keep all their data global. The doppelgangers and Richter, because they're playable characters as well, to keep the code effectively the same, they get their own player state. And a lot of their logic then is just manipulating that player state as if you were had a controller and were controlling them. And so they when Richter wants to do a slide kick, for example, you'll see that the virtual control pad for Richter has the down button pressed as well as the jump button. So that's kind of the difference between the two. I hope that makes sense. Let's look at... Okay, there's two things I want to do quickly. So we have our entity Richter. We can go through these and see which ones we still have not looked at. I'm pretty sure BDO we did. A14, I think we did that one as well. Disable after image possibly is a larger function. Some of these drawing functions, I remember this from Doppelganger as well. Basically, what they do is they go through each pixel of the current sprite that's being rendered to determine how to. No, that's actually I'm thinking of the like the glow, like when you when all your mana is refilled and you get a white outline. That's the function I'm thinking of. After image might not be that bad. I'll have to. We'll have to look at that. What I want to consider is, should I split this file? I think it would be right here. Main, yeah, main comes early, and then entity Richter would be at the end of this file. That makes sense to me, to go along with these others. That means I have to find where RO data is split to, which may or may not be difficult. Let's look at the steps. The steps starts with Rick stand. And there's this BO4 function before it, which is called we don't have an equivalent in here. I'm going to just make a note for myself that this is a possible file split. There's two reasons that we would split a file. One is because logically it makes sense, especially for stage files that are duplicated across all of the bosses and stages, but maybe not necessarily in order. The other is that something about the way the object was compiled suggests to us that there is a file boundary. Usually that's alignment. When you have a jump table, we just dealt with a bunch of jump tables. By default, GCC will pad those to some multiple of 16 bytes. And so if you see that a jump table isn't aligned to that 16-byte boundary, it's likely that it was a new file, and when the new files are compiled in, they're just slammed right up against the end of the old file without any of that padding. And it's not reproducible any other way. So those are kind of the two considerations. Hey, Spring Quetzal, good to have you back. Sorry, looking over here. All right, I'm gonna go through these quickly. Having everything in one file is convenient, but also not necessarily sustainable. Oh, the BDO file is not decompiled. I thought that was something that we looked at. No, I guess not. There may be others. I used the last 3 or 4 digits in the file, but obviously those repeat. So that's an option. Let's look at this A5814. That is called everywhere. I think that one is decompiled. Is that the set step equivalent? Possibly. Disable after image. That one is not done. Let's look at that. Oh, that one's done already. Sorry. There's our video. again. Oh, it is a different BDO. That's the one that we did. No, that isn't the one we did. It is. No, it is done. I don't know why. I couldn't find it in decomp.me. And this 998 is done as well. So yeah, let's look at this top video. Mid-sized function. And we could, I don't know if we have a good sense yet of whether this has an analog. So we have some things that look like they're in the entity table that we haven't mapped yet. Might be able to get a few new symbols out of that. Spring Quetzal. Spring Quetzal is talking about looking at old C++ assignments and binary trees. Yeah, there's actually a when I was looking at SPIM recently, there's a case where they're putting symbols in order, and a binary tree would actually work really well, but instead they're using a just a sorted list of keys, which actually isn't that bad either. But a B tree would be the best of both worlds, and as far as I can tell, there's not a built-in B tree like data structure in Python. The number of like highly optimized built-in data structures is really small, and I understand like it wants to be simple, so it's gonna just do the lowest common denominator thing. Like you have a dictionary, you have a list, okay, and that's it. But having access to some of those nicer symbols, or nicer, sorry, I'm looking at this, nicer data structures that are purpose-built for particular problems is useful as well. Oh, see on the test for Calc 3, that's a bummer. Desic says, do you know how is determined which compiler version with which parameters is the correct one? Yes, brute force. So we do a couple things, and actually I've been meaning to write a tool to help people find this, because we know enough, and I just need to go through and compile enough games where we know what compiler and compiler settings. But one of the things that we have, it's not perfect. It would at least help you find the SDK. We know that the basic stub of any of these PlayStation games is going to be a main that effectively looks like this. You get your basically you're just waiting for various things to happen with the CD drive. So you open your CD file and you kind of wait for the state of the CD drive to change. Then you load the data from your CD file and you do the same, and it's all happening kind of DMA in the background. And so you're just kind of polling this until it happens. But then within that main, so these are the SLU files that you'll see on a PlayStation disc. You also get any of the libraries that you linked from the PlayStation SDK. So these are the libraries that Soten links, and all of these are very unique to an individual SDK version. And so if you're using, so in this case we're using the 3.5 SDK, the likelihood that you're also using GCC 263 is pretty high. And so finding out which version of the SDK you have points you basically to what compiler you have. And then how do you find what what compiler flags? That's tough, and yeah, it is kind of a brute force thing. So once you find the compiler, it's not too bad on the PlayStation because you're going to be using some version of GCC. There you'll see SciQ in this list. That's just the PlayStation SDK, what it was called before, like 2000. SciQ, interestingly enough, I'm pretty sure was written by Psygnosis for the Sega CD, and was ported, like a lot of it was ported to the PlayStation. It's tooling that was meant for that. Psygnosis, obviously, they wrote Wipeout, among other things. Very did a lot of optimization. I'm pretty sure that's where that came from. On the PSP, on the other hand, you could be using MetroWorks or you could be using GCC. I don't know what SN is. Not familiar with that. MetroWorks stinks because it's not as readily available, and there's been a lot of difficulty finding different versions of that. But that is available, and then again, like what the flags are, you kind of have to go through. And so if you can find something, some like anchor point, like the main function, you can get a pretty good idea of what it should look like, and then you just go through optimization settings and other things until you find one that gets it really close, and then you should be able to make it the rest of the way. Spring Quetzal says, here's a real life use of binary trees. Believe it or not, there is. The other thing that would work really good for that particular use case, and I keep meaning to write a generic implementation of it and just never get around to it. For Clojure, CLOJURE, which is a Lisp for the JVM, Philip Bagwell wrote a paper about something called ideal hash trees, and they work a lot like binary trees, except instead of being binary, they have 32 nodes at each level, and the way that you index those nodes is novel and makes it relatively inexpensive to find things in like log 32 time instead of log 2 time of n in both those cases. So the performance starts approaching like array performance, but you get the search capabilities of a tree, which is pretty cool. And splitting by 32 as opposed to splitting by 8, it's constant, but it does have real world implications. All right, let's get back to this function. So there's a couple things that I want to look for. So we're allocating primitives, we're setting the time attack controller. Do we have an analog to this in Richter that I can crib most of this code off of first? Because if we do, then I will use it. Nope. Look in Richter. So I'm going to start with in PL main, and then we'll go to steps. So the things that are happening is all of the colors are being set to basically half intensity gray. And that'll be another obvious tell. That's not right search. So here we have something like that, but it's in a much, much bigger function. It says set step dead. I don't think the stand, called a stand, is going to be in here. What other Z priority? So this unknown graphics struct. There's exactly one place that this is getting set, which is Rick and Knit. And that makes actually a ton of sense to call this Rick and Knit. What may be happening if this color is being set, there's some macros, and I always forget what they are. There's some macros to set like all of the colors when you're setting a gray. P gray? No. All right, so I'm gonna keep this off on the side and watch it. I think that'll probably be relatively close to what this function is. Oh, we'll do some cleanup first. That won't be necessary. This won't be necessary. Anything that is grick underscore, I'm going to turn into grick dot. Anything that is rick underscore, it's going to turn into rick dot. Right, so then we have a few more. I'm going to do a search for these. See if those are defined anywhere yet. Nope. And if they're not, then we'll see how they're used. So I think this is an animation frame pointer. So this is probably an animation frame array. And then here we have an array of some type. We're doing this call to rsign, which is going to return a 32-bit value. And our offsets are by 4, so I'm going to assume that this is a sign 32, which is 4 bytes. And then a few more issues here. 70, we turn that into array access. 80, I couldn't figure out what this was. Likely not an Actually, it could be an entity, but I think it's off. Let's go back to Richter. So this is pulling from sprite parts. It is of entity size. So Varus 0 should be at an entity, and I think what has happened is that there has been some optimization that shifted that assignment. We saw that in an earlier Richter function where what gets stored in var s0 when it compiles is not on the boundary of a struct, but somewhere in the middle, so that the offsets that it can calculate are cheaper. So this is ultimately going to become a loop. I'm going to replace var s0 with an entity. I'll call it E to match what was in Rick, and then we'll set these to be the same thing. And I'm just getting this from the Richter implementation, so when this is compiling, I'll have to come back and see. This is actually what it is supposed to look like. We'll get our for loop going. It does look like E is getting stuff there. My guess is that this is probably probably somewhere around GNT 64. We'll figure that out in a little bit though. And I need my eye. All right, 84. Not too bad. So we have a lot of, quite a few gross looking functions in here. We'll get this cleaned up and then we should be good. Gross looking variables, sorry. We call this prim usually. The primitive buffer, so kind of like we have this entity buffer. There's a limit to the number of entities that can currently exist at one time. I think it's 256. So on screen there could be on screen or like being tracked in a room, there can be about 256 things. So that means they could be off screen, but you want to keep track of what their position is. So if you walk over there, you know where they are, or if they're alive or dead. There's actually some interesting differences between the Japanese version and the US version regarding that. There are characters that will respawn off screen in the Japanese version that don't happen in the US version. But it's things like that. Everything, you get about 256 slots for things you want to. It might be 128 or 256, one of the two. Primitives are every quad that you want to draw on the screen. So entity usually has, but doesn't have to have, one or more primitives. And that has its own separate table. And when an entity is being initialized, it will go through and ask for, in this case, 6 primitives. So Richter has 6 sprites, basically, that it can use. Okay. On the PlayStation, there is no native sprite handling, and so you get a 3-dimensional quad. You face it directly at the camera, and then you draw. You size it so that it's exactly the dimensions of your sprite, so you don't get any odd shimmering effects. And then what you get back, even though it comes from a table, is a linked list. And all of the entries in that linked list are back in the table, but not necessarily in order. So you don't have to allocate contiguous blocks. So here, Varus 2, typically Varus 2 is what is used for I. Just so happens to work out that way. It must be something with this version of GCC that it wants to use I. So looking again back at Richter, how does this work? It's setting radius and intensity for something. Not sure what. GCC will do this a lot, where we want an index into an array, and it says this optimizes better if I pull out the initial address and then just increment the array along the way. But then it doesn't always do that. So why does it do it sometimes and not others? Your guess is as good as mine. Let's just give it the name radius, which I'm happy to take. And this was given the name intensity, which I will take as well. And it looks like I broke something along the way. Maybe this for... How much closer? About 4% closer. Most of this is just cleanup so far. In the Richter version of this, this is assigned inline in the for loop. I don't think it's going to make a difference for code gen. I'm going to do it for consistency with the other one. I don't like, that's not my favorite style, but I will. I'd prefer to be consistent than have my own personal preferences met. This might be... No, this is the right order. I'm looking at this add versus move here. Oh, there's add 9. Maybe that's what this is. Yeah. The original was add 1. Not knowing what unknown 5a is, it's hard to know exactly what that operation, what the meaning behind it is. Multiply by 16 and then shift by 4 again. Like, we think of those as the same thing, but the compiler is going to produce different code for both of those. I might want to put a float here. So this is 1/16. Yeah. This works because GCC will convert this to the appropriate thing at compile time. So even though there's no floating point division that happens on the PlayStation, the compiler can do the floating point division and figure out that this is going to turn into a hex 100 and put the right value there. And we get the benefit of the nicer, or like understanding more about what that is. I don't always go from bottom to top, but in this case it seemed like it made sense. The F4 that's going into this just happens to be in the A1 register, and it's not something that is actually being passed to that function. If we had declarations for the function, the compiler probably would give us a warning. We don't have them necessarily, so we don't see anything. This is interesting. So this is this section up here. If you look at what was happening in the original one, we're doing like a mem set to 0. I'm going to try using the built-in mem set, because that would be nicer. Bar A0. So that's Richter. So yeah, we're clearing out Richter. The args for memset, I think, are what you want to set, how much of it you want to set, and then what you want to set it to. The F4 is interesting. It's actually smaller than I would have expected. Oh, F4 times 4. And if I'm expecting that to be 3DO. Yep, 3DO. No, yeah, it doesn't get the right thing. Oh, it's not using the built-in. What function am I thinking of? Yeah. Oh, wrong order. But we're not getting... It's getting called as a function instead of getting compiled. Memcopy? No, memcopy does not do that. Let me look at what the other functions are in this. It would be memset. I really thought that there was a built-in I have no built-ins. The built-in prefix should override that though. Let's see if memset is used elsewhere. Yeah, we do. I would expect the compiler. So when there's a built-in function, what should happen is you generate the code for it as opposed to calling a function. Yeah, but the middle arg, Christiana says it looks like a size because it's unsigned. So for memcopy, is the last arg really a size T? Probably not for the PlayStation SDK. It is for like POSIX libc, but that's possibly too modern for what we're dealing with. It probably wasn't int. Things were a little more loose back then. So like, could this be size T here as well? Probably. The unsigned char is that even the right signature? I don't know. Let's look at the SDK and see if we have. It does come up as unsigned, and the docs do say unsigned. And what about the header? Where is libc.h? Sorry, just looking at. Oh, did they not? No. So in the SDK, they actually leave it as an undefined set of arguments. This is the type or the function declaration that you get in. I really thought it would be a built-in though. Let's do this. Actually, there's a fun way to get around this. So we can set this to a zero-sized array. And that does, yeah, or not zero-sized, an array initialized to 0. This, regardless of what the size is, this will fill this all with zeros. And so this is what the compiler would generate if it was doing a memset. And so we know that that's not what's happening. Sorry. All right, so if you can't find the memset built in and you want it anyway, you can assign a struct. You have to cast this, but to a struct or array looking thing with just a 0 in it, and that will fill the entire size of player state with zeros assigned to this global location. This is the code that we generate, and what where's our what is going on? What we have is actually much more efficient than this. By efficient, I should say, it's actually not, it's less efficient, but it generates less code. Why is it less efficient? Because we're incrementing by 4, and then setting 32 bits at a time. So we have to set 4 bytes branch, set 4 bytes branch over and over and over. Here we're unrolling that by 4 times. So this is more efficient from a runtime perspective, but less efficient from a memory code in memory perspective. So let's do what they did. And my guess is, because this has been decompiled for the PSP and it works like this, that this has been vetted there as well. This is kind of a little too loosey-goosey for me, but it's what it is. You gotta kind of go with it. The memset len, this is actually a compile time constant. And yeah, we probably need to cast it. It just so happens that this struct is aligned. On a 4-byte boundary. And so we can get rid of this. Kudos to whoever found that. I probably would have been trying to find all ways to cram it in to one of the built-ins. Is that it? Did we finish it? No, we didn't. Some assignment up here. I'll deal with that in a second. And we have to figure out what these other symbols are. Yay, symbols. Get rid of this and this. Get rid of all these extra variables. Spring Quetzal. Let's say you wanted to contribute to decomp. What is the road plan to learn to help? Yes. Knowing C is important. Is it the most important thing? There's so many. It's pretty important to have a pretty solid understanding of C. The main thing that I think would be hard for even modern C programmers is you have to know what C was like in 1995, which is a little different from now. Most of it's the same. Then you have to know not only what was different then versus now, but what parts of that matter, because we are able to do a bunch of things that look modern, but then maybe they're taken care of by the C preprocessor, and by the time it gets down to the compiler doesn't know, or the assembler doesn't know, depending on what layer it is. Okay, so learn you some C. Then the next thing I would probably do is if you have some understanding of assembly language, it doesn't have to be necessarily the assembly language that you're targeting or want to decompile for, but some language. And it could be bytecode for a language too. That's just as good. It does the same thing. But understanding like what a low-level machine looks like as opposed to the compiler. Or sorry, the higher level language, and how those things are gonna be represented. So what does JAL do? Jump and link. There's only 24 instructions that are used that I've come across so far in this language, so it's pretty small. Most of those are things that make sense. There's things like move that don't have a huge analog, but sometimes they're assignment, sometimes they're just storing things off. Understanding stack and heap, mostly stack for this stuff, because there's not a lot of dynamic allocation in older games. And then we have in the wiki, if Soten is like the thing that interests you, this is one of the best documented and I don't know, the way this project is run has been fantastic and made it really easy to onboard. I had done some reverse engineering, never matching decompilation, a bunch of C, and I knew MIPS. So I had that kind of going for me, but then the way this project was set up was really nice too. So we have a list of functions that aren't decompiled and what section of the game they are. And then if some of them are started but not finished, you get that as well. So you can come here and see, okay, so somebody was working on this cat function, or cutscene unknown in Sen. Maybe not that one, because Sen is an older overlay, and so if somebody hasn't gotten that one yet, that might not be the best thing. But there's some details in here that may or may not make it easy. Looking at the duplicates, that's nice, because we know that there is another function that looks like that. So we have other examples to follow. I'm really surprised that Sen is showing up here. And then these links, I think, no, they won't. These used to go to call graphs. Some of these will take you to the best scratch that we have so far of it. And this isn't a good example. It's going to be a reasonably complex function. But yeah, finding something small. The way that I find the small things, and this is just the way that I do it. Is there a graphical way to do something like this? Find everything in non-matchings and then sort by size. I guess, yeah, you could, if you had this open in a file editor, that would be fine as well. This recurses though down into the directories, but choosing one of these files and say, for example, so set speed X, it has a name, it's small, it should be easy to do. Some of these are so easy, you don't need something like decomp.me. What does this do? This returns 0 and nothing more. How do I know that? JR is the jump return instruction. It's returning to RA. RA is the return address register that gets set by the caller when JL is called. Add U. Getting some of these like idioms and idiosyncrasies of how the compiler does things. We could use the move instruction to move the 0 register into V0. V0 is the return value. But But for whatever reason, GCC decided that it's going to add 0 to 0 and put that in there, and what's the result? 0. Is add U cheaper than move? Maybe. It's hard for me to imagine that it would be, but it could be. Would a MIPS decoder decode this to the same thing? It might end up being the same thing. I don't know. So let's do that though, and prove that I'm not full of baloney. So it's going to return an int. It may or may not take arguments. We don't know, because it doesn't use them. But yeah, that's all that function does. So return, what are we returning? What's in B0? What's in B0? 0 plus 0. So I think those are kind of good things. Oh yeah, that's true. Thank you, Cristiano. That's that is a huge complication with MIPS. Let's go back to that one. When you're branching in MIPS, you execute the instruction immediately after the branch, and the branch doesn't complete until that instruction is completed. Which is, yeah, kind of funny. What's interesting and difficult about the PSP is it would have a, I think it's JRI. I think they're suffixed with I. Any of these branch instructions, they have alternates on the PSP that don't execute the instruction immediately after them. The way that SPIM designates this is it indents it by 1. Why 1 space as opposed to like really indenting? I don't know. I would like this to be a little less subtle, but anyway, that's what that does. So that's some of the things. Like I said, Soten Decomp, setting up a workspace, if you're familiar. So everybody working on this is doing it in a some type of Linux environment. Some people are using WSL on Windows. I just use a native Linux desktop. So that's another thing if you're not familiar with Linux. That may or may not be difficult. Unfortunately, there's some tools that we have in here that can't run on modern Macs. I would love for this to build natively on a Mac. But for the PlayStation and PSP stuff, we can't do that. But this has lots of documentation on getting your environment set up. I haven't been searching because I like this project, and I'm going to stick around, I think, until we get at least one version done. But coming into this project a little over a year ago, I was able to get set up and get going, and get PRs sent out within less than a week, I think. And I think that's pretty good for a project that I had no familiarity with beforehand. Okay, so we have let's find some symbols, and then we'll hopefully get this wrapped up. What happens here, we have these globals, decomp.me and M2C. They don't know what those are because they don't have names. We don't have names to give them. So let's give them some names, and then we can find out where they are, and that may or may not change how things get compiled. It doesn't look like it will. It looks like they're being accessed by like directly addressing them. Oh, thank you for the music. Compliment. So all this music is YouTube creator music. All of it's free. Some of it's pretty good. Some of it's less good. But I used to play game soundtracks, but you get like demonetized. And that's no fun. Alright, so I want to see where these are. I'm assuming that they're part of Richter. I'm going to go up here and try to put these in order. Alright, F0, that looks like it's right where it needs to be. F2, 6, and 332. Maybe out of range. Oh, we haven't come across draw mode yet? That's surprising. Alright, so how far after this are we? We're 4 bytes after the current frame. So it looks like unknown 5A. I didn't have unknown 5A either. Alright. So that doesn't help us a ton. I will put those in place. Actually, it will help us. And what were the other two? Scale X and Scale Y? All right, this unknown graphics struct Z priority assignment. I'm gonna go back and look at we have a name for this though too, Rickinet. That's good. The current entity is getting set. We're not doing that in our version. Destroying the entity, not doing that. Position X and Y, that doesn't look like it's happening. The Z priority is getting set way up here, which is different from what is in ours. So I'm going to try moving it up. My assumption in a lot of this is and flags getting set differently. Let's move that down. Yeah, that worked. My assumption with a lot of this is that most of this code is just copy pasted, and then there's the difference is necessary. So usually ordering is going to be the same. The way different structures are set up, the way switches are set up, those are all going to be the same. Interestingly, whoever was working on this did not catch the pass-through assignment. So I just want to make sure that all these are done the same. Draw mode is not being set here because it's being set dynamically, I guess. No, it's not. Draw mode's not being set on this one. Flags is not either. I'm going to move flags down. Interestingly or not, depending on what you find interesting, that may or may not affect, like a lot of these assignments don't necessarily affect the order that the work actually gets done in. We can watch these offsets here as I move this line around, because I've not marked it as volatile. Those don't change as I move this up and down. And so what is the right position? We'd have to grab the PSP version to find the right one. I can't remember offhand. The order flags is usually set with the rest of these. I'll put it back where it was though. So it's possible that one or more of those is out of order, but everything else looks good. So let's try it. I didn't clean up the extra variables. I think this is BD. Oh. I want it. So all of these globals can go away. They were all part of the Richter entity. And something terrible happened along the way. Oh, there were two more that I didn't get. Okay, we'll keep them in there for now. I think it was these bottom two. So there's a 9-4 and a D8. The original had a 9-4. Let's figure out where that is. 3-4 D8 is our instruction. So it's after this 801. Somewhere in here. Let's go back over and see if we can reproduce. Was it missing? Somewhere around line 64. Back. So we have a D8. And we should be generating a 9-4. Trying to figure out which instruction that is. So we should see 9463. All right, so it's this add actually. Oh, it's. I got the wrong. I think I got the wrong field. Oh, it's this here. Duh. I knew that this was. I just guessed. So how far off are we? D8. My guess is that it's BC. So we have D8 minus 9-4. Oh, the offset's 44. Suck. That's not a good offset. Oh, it's 63. Oh, good. I can deal with that. Let's try again. So we need 6394 minus 62E8, and it's BC in size. So this is stage entity start, or yes, it was good. +1. I can deal with that. There we go. All right. Another one in the can. Oh, 2.5 hours. I've been doing this for a while. 2 hours and 15 minutes. Thanks everybody for joining Spring Quetzal. Christiana roaming. Appreciate it. Dizik, of course. Thanks for all the help. Appreciate everybody showing up. And we'll be back tomorrow doing more decomp. Got 2 finished today. And tomorrow, what will we get finished? Who knows? More. That's all I know. Adios.